Okay, so this is an introductory topic video for iGCSE Physics, 8B Astrophysics on orbits. So key maths, the relationship between orbital speed, radius and time period is V is distance travelled over time taken, or orbit. So that would work out for a circle, of course, 2 pi r, or pi times d, so that's your circumference. And obviously it takes you an amount of time to get around that circle. So it's 2 pi r over t being the time period. Now to work out V, of course, it depends on what r and t are for units. So time could be in hours, seconds, minutes. Distance could be kilometers or meters. So you've got to be able to convert hours into seconds or days. So 24 hours is that many, 86,400 seconds, kilometers into meters. And so you've got to be flexible on your units. That's the tricky bit. The equation's always the same. We also should know about something called an astronomical unit. They'll often give you a bit of information on this, but the clever part is an astronomical unit is the distance from the Earth to the Sun. So if we think about relative speaking, Mars is further away, so it's 1.52 astronomical units, or 1.52 times 1.49 times 10 to the 11 meters. Clearly the reason is it's a lot easier to deal in AUs than it is in lots and lots of meters. We should know what an eclipse is. So it's basically if things are orbiting, so you've got the sun coming in this way from the left, and when the Earth and the moon are aligned like this, and the moon's behind the Earth, we get a shadow. It's just the absence of light. So it could be partial, it could be full. So in the case of the moon, we get an eclipse here, but people can still see stuff here. So it's just being able to talk about eclipses. Gravity then, bit of mathsy stuff. So the gravitational field strength, it's important you call it grav field strength, GFS. G is different under the planets and the moon from that on Earth, whereas G is 10 newtons of pull for every kilogram of matter, or 10 meters per second squared, or 10 ms slash s to the 2, or m slash s slash s. That would be on Earth. On other planets, it's different because they are clearly different sizes, different masses, different radii, that kind of thing. So the gravitational field strength creates a force which causes moons to orbit planets. It pulls things together. And we use the formula weight is mg, or F is ma. They're basically the same equation. Now, things in the universe. I see no end of people making a mess of it. It's simple. You've got to learn it. Universe contains everything we know of. The galaxies are collections of stars and matter. The stars are just hot balls of gas fusing. There's one. It's called the sun, but it's actually a star. Solar systems have a star in the middle. There could be a solar system. We've got planets and dwarf planets. They orbit the star. Dwarf planets are very small planets that are not really big enough to be called a planet, and their gravity is pretty weak. So we call them a dwarf planet. Moons, they orbit the planets. Comets, they have these usually elliptical orbits that go around the suns or the stars. They come around every so often, and we see them and they look cool. And they're made of rock and ice. Asteroid, just a lump of rock floating in space. We have an asteroid belt further out in our solar system. If you hit stuff like meteorites or asteroids, it's not good. But a meteorite is just an asteroid that falls in the atmosphere of a planet, burns up often as it arrives. Satellite then, in a stable orbit moving at a constant speed in a circular orbit at a particular distance from the object it's orbiting, would be a satellite. But if we remember that vectors such as velocity have magnitude at size and directions, it has a change in velocity. So because the direction changes, we say it has a change in velocity, even though it's traveling at a steady speed. You've got to try to recognize these types of pictures to label satellites, planets, comets, and suns. Again, it's simple if you learn it. So there you go, 8B Astrophysics.